Hi everybody, this is Professor LaShan and I'm going to go over some of the examples from section 5.3. I'm going to shoot some videos here from section 5.3 going over the examples starting on page 252 from section 5.3. So I'm going to start with example 1. And in section 5.3, it's really the reverse of what we learned to do in 5.1 and 5.2. In 5.1 and 5.2, we would be given a z-score, we'd look it up and get area. And then based on the picture we drew, we would finish it by then looking up the area and either keeping that as our answer, adding, subtracting, various things, depending on the picture we drew. Now we're going to go in the reverse direction, which is often harder for students, which is given area, find the z-score that goes with it. So if we go for example 1, number 1, on page 252, it says find the z-score for a cumulative area of 0.3632. So let's draw the picture so we can figure out where we're going here. So this is the standard normal distribution, not applied data. So in the middle, our population mean mu, the z-score is 0. We're not using applied data here. And so if this area here is 0.3632, that's less than 0.5, 50%. Remember that on each side of the mean under the standard normal distribution is 50% of the area, 100% total under the curve, or 0.5 on each side, which adds up to 1. So this is less than 50%, 0.5. This is like 36%. So that means that the z-score we're looking for has to be over here to the left of the mean. And the cumulative area really means the area to the left. And what they're telling us is we're looking for this area, 0.3632. So that means our z-score based on where we are has to be negative because the area is less than 0.5, 50%. So what we're going to do is we're going to go to our z-tables and we're going to go to the negative z-table. And again, this is a little bit of a different skill we have here. So now we're looking for this area, 0.3632. So you just scan through these numbers, they get progressively larger, and you always hope to find an exact match of what you're looking for. And there is an exact match. It's towards the bottom here. I'll put a black paper here so you can kind of see it. Towards the bottom here in row negative 0.3, we do find an exact match right here above my blue pen at 0.3632. So that's for a z-score of negative 0.3 is the row, and then we have to look up and 500ths. So negative 0 for the ones, 3 for the tenths place, and the hundredths place is 500ths. So that means our z-score, our answer that matches up with an area to the left of 0.3632 is a z-score of negative 0.35. Okay, so now if we go to number 2, which is a trickier question, and remember the table always gives us the area to the left. That's just how our table works. So number 2 on example 1 says, find the z-score that has 10.75% of the area to its right. So this is a harder question in a couple of ways. So up in the first question, cumulative area, that always means area to the left. That's what our table gives us when we look things up. This is giving me the area to the right, which is not really what I want, but it'll help me get to the answer I'm looking for. So in the middle is our mean, where z-score is 0. 10.75%, that's less than 50% of the area falls to the right. If we were here at the mean, 50% of the area would be to the right under the curve, 50% would be to the left. This is saying 10.75% is to the right. So that's less than 50% falls to the right. So we must be over here in what we call the right tail. And this area is 10.75%. But that's never what we look up, the area to the right. We need to find the area to the left. And we have to use this idea that under the normal curve, as we know, the total area under the curve is 100%, or it's a percent, or 1 is a decimal. So if I want to know the area to the left, which is actually what I need to know to get this z-score here, I'm going to have to take 100% minus 10.75%, which is going to give me 89.25%. 89.25%. Now, 89.25%, percent is never what we look up. We actually want to look up a decimal. So I'm going to move my percent to a decimal. I'm moving 2 places to the left, which gives me 0.8925. That's all of this unshaded area. It's 89.25% because there's the other 10.75%, which adds up to 100%. So now where am I going to find that? On the positive z side, because that's where we are. So we're going to go to the positive z side. And by the way, you won't find a number this big on the negative z side anyway. So even if you look on the wrong side, it's not there. So what I do again is scan through these numbers in the area. They get progressively larger, and we're looking for 0.8925. And again, there's an exact match above my green pen here. There's an exact match here at 0.8925. This is in row 1.2, and you have to look up to get the hundredths place is a 4. So 1 for the ones place, 2 for the tenths place, and 4 for the hundredths place. So the z-score that matches to that would be a z-score of 1.24. That has 10.75% of the area to its right and about 89.25% of the area to the left. Again, we always have to look up the area to the left. So now I'm going to go to the next page, and we're going to go to example 2, which is on page 253. And in example 2, it's going to use the idea of percentiles, and it has 3 questions. I'm actually going to do them a little bit out of order because it turns out the first one's the hardest one. I'd rather start with the easiest one. So I'm going to start with example 2, number 2, which gives me p sub 50, or the 50th percentile. So let's draw this. If you recall back from chapter 2 when we learned about percentiles, putting the mean in the middle of the population with a z-score of 0. When we learned about percentiles, remember there was a question I asked on test 1 from chapter 2 that said, if you score at the 70th percentile on a test, what does that mean? And the answer was about 70% of the other students scored lower and about 30% scored higher. In terms of area, at the 50th percentile, that means about 50% of the area under the curve is below or to the left, and about 50% is to the right. So we're going to actually shade what we want. Now, because this is exactly 50% here, doesn't that just correspond with the mean? Because at the mean, where z is 0, 50% of the area to the left or below, 50% is above. We always want to look up the area to the left. So what I'm looking for is I'm looking for this area, 50%. Now, you don't necessarily have to use that. And by the way, when I turn area or percents into decimals for area, I always put 4 decimal places because that's how it shows up in our table. So we know this is at the mean. We actually already know the answer for this problem is that the z is going to be 0, the z-score, because you're at the mean. But let's look it up in the table to show you that you can also find this in the table. You can go to the positive z side of the table. We're looking for 0.5000, which is 50%. Guess what? That's the first entry in the table right here. And notice what's my z-score? 0.0, looking up, 0. So 0.00, which is just another way of saying 0 for our z-score. You could also say, well, what if I look on the negative z side? Guess what? That's also on the negative z side of the table. If I go down to the very last row, and I'm looking for the area, 0.5000, it's actually the last entry here in the table. And what's the z-score? Negative 0.00 hundredths, look up. And so negative 0.00, that's just 0. 0 is not really positive or negative. So in other words, at the 50th percentile, where are you? You're at the mean. And at the mean, the z-score is 0. So that's what, so far, everything we've looked up has always had an exact match in the table, but that's not always true. So if we go to example 2, number 3, and we do p sub 90, the 90th percentile, again, in the middle is our mean. We're in the standard normal distribution, not applied data, so z is 0. We're saying 90% of the area under the curve falls below wherever z is, or to the left. Well, 90% is more than 50%, so we have to be over here somewhere. For 90% of the area, draw a line so we don't get this confused. For 90% of this area to be in blue. Well, I'm going to turn that into a decimal. 0.9000. It's really 0.9, but again, our areas always have 4 decimal places. Where are we going to look for that? On the z is positive side because we're to the right of the mean, and you won't find an area that small anyway on the negative side. Again, we always look up the area to the left. No matter what they give us in the problem, we have to look up the area to the left. So we're looking for 0.9000. So far, everything we've looked for has had an exact match, but that's not always the case. So if I start scanning through these numbers, the first 0.9 something is 0.9015. Hopefully you can see that above here. A little bit of a contrast here. Let me move that down so that's better. There you go. All right, so 0.9015. That's a little bigger than we want for 0.9000. It's about 15 10,000ths bigger. So let's see if the one next to it is closer. 0.8997. That's a little too small, but it's a lot closer. That's to what we want, 0.9000. It's only 3 10,000ths away from what we want, whereas this one's 15 10,000ths away. So if there's not an exact match in the table, pick the closest value. Could be more, could be less. And so what's the z-score? I'm in row 1.2 and 800ths. So my z-score that most closely matches to having an area of 90% or 0.900 to the left, 0.9000 is the z-score of 1.28. Okay. So let's go to, again, I did these out of order. Let's go to example 2, number 1, because that's actually the hardest of these 3 examples from example 2. Which is page 253 again. And so that one we want to find p sub 5, or the 5th percentile. So this means 5% of the area falls below the z-score, 5%. So and again, in the middle is our mean where the z-score is 0. 5% is less than 50%. So it's much less than 50%. So where must we be? We must be over here. If only 5% of the area falls below or to the left. If we were over here, it'd be more than 50% would be to the left. So changing that to a decimal, 5%, moving 2 places to the left, I have 0.05, and I'm going to add 2 zeros again, 0.0500. Let me make that a little bit neater. Try that again. 0.0500. That's what I'm looking for in the z table on the negative z side, because that's where I am. I won't find a number that small on the positive z side. It starts at 0.5, 50%. So again, I'm scanning through these areas. I'm looking for the first 0.05 I can find in the table, which is down here in row, let me pull it up, in row negative 1.6. Straighten it a little bit. So 0.0505 right here. That's a little too big. I wanted 0.0500. That's 5 10,000ths too big. So I look to the left. 0.0495. That's a little too small, but it's 5 10,000ths too small. So actually what I'm looking for, 0.0500, it's a tie between these two. So the way this book does it is we can't just pick one or the other. We actually have to average the 2 z-scores that go with these 2 areas together. That's just how this book does it, and we want to get the right answers for the book and MyStatLab. So we have to take these z-scores, negative 1.65 and negative 1.64, and the area I want was halfway between these areas, so the z-score I want is halfway between those 2 z-scores. So let me show you how you do that. So you take the z-score of negative 1.65, the z-score of negative 1.64, and we average them. When you average something, what do? You add them together. So we get 9, we get 12, we carry the 1, negative 3.29, we divide by 2 because we're averaging these 2 numbers. So the z-score we're going to use is negative 1.645. So sometimes the area you want is exactly halfway between 2 areas in the table. You have to average the 2 z-scores then. Sometimes the area you want is closer to one of the areas in the table, so just pick that z-score, whatever's got the closest area. And sometimes you're lucky the area you're looking for is exactly in the table, so that's the z-score you pick. So I will continue on another video with the other remaining examples in this section 5.3.